Hello everyone. In previous class, we discussed about what is harmonics, current harmonics, voltage harmonics, and its elimination methods. In this lecture, we will study about what is the excitation system used in alternator or synchronous machine. After this, we will move on the elements and signal of the excitation system. Next topic is the types of excitation system, like DC excitation system and AC excitation system, and finally the references of this presentation. So in this lecture we cover all these topics one by one. So let's start with topic excitation system. So the first question is that what is excitation system and why we need the excitation system? So the definition of the excitation system is the system which is used for providing the necessary field current to the rotor winding of the synchronous machine. Such type of system is called an excitation system. In other words, the excitation system is defined as the system which is used for production of the flux by passing current in the field winding. The main requirement of an excitation system is reliability under all the conditions of service, a simplicity of control, ease of maintenance, stability and fast transient response. तो एक्साइटेशन सिस्टम का मीन क्या है? एक्साइटेशन सिस्टम का मतलब फील्ड वाइंडिंग को अगर हम सप्लाई प्रोवाइड कराते हैं या करंट फ्लो कराते हैं जिससे कि हमारा एक फ्लक्स बनता है, तो इस सिस्टम को हम बोलते हैं एक्साइटेशन सिस्टम. रिक्वायरमेंट हमें क्यों है एक्साइटेशन सिस्टम की? सिस्टम को रिलायबल रखने के लिए, सिंपलिसिटी ऑफ कंट्रोल रखने के लिए, ईज ऑफ मेंटेनेंस एंड फास्ट ट्रांजिएंट रिस्पॉन्स सिस्टम का लेने के लिए हमें एक्साइटेशन सिस्टम की जरूरत होती है. The amount of excitation required depend on the load current, load power factor and speed of the machine. तो एक्साइटेशन जो है वो तीन चीजों पर डिपेंड करता है: लोड करंट, पावर फैक्टर एंड द स्पीड ऑफ द मशीन. The more excitation is needed in the machine or in the system when the load current is large, the speed is less and the power factor of the system become lagging. The excitation system is the single unit in which each alternator has its exciter in the form of generator. The centralized excitation system has two or more exciter which feed the bus bar. The centralized system is very cheap, but the fault in the system adversely affects the alternators in the power plant. This is all about what is excitation and why we need the excitation. The next topic is elements and signals of the excitation system. So this is the block diagram. The general block diagram for the synchronous machine control system is shown in a figure. The figure consists of 5 blocks. They are control elements, exciter block, terminal voltage transducer and load compensator. The synchronous machine and power system and power system stabilizer and supplementary discontinuous excitation control. तो ब्लॉक डायग्राम में हमारे पास 5 मेन ब्लॉक हैं. पहला एक्साइटेशन और कंट्रोल एलिमेंट्स, सेकेंड इज एक्साइटर जो कि हमारा डीसी सप्लाई होती है, थर्ड इज अ टर्मिनल वोल्टेज ट्रांसड्यूसर एंड लोड कंपनसेटर, नेक्स्ट इज अ सिंक्रोनस मशीन एंड पावर सिस्टम, next is the power system stabilizer and supplementary discontinue excitation control. So this is the basic block diagram of the excitation system. When EFD is the synchronous machine field voltage or exciter output voltage, IFD synchronous machine field current or is the exciter output current, IT is the synchronous machine terminal current phasor, VC is the terminal voltage transducer output, VOEL is the overexcitation limiter output, VR is the voltage regulator output, VS is the power system stabilizer output and VSI is the power system stabilizer input, VREF is the voltage regulator reference voltage and VUEL is the under excitation limiter output. So the next is a types of excitation system. The excitation system is mainly classified into three categories. They are number 1 DC excitation system, number 2 AC excitation system and number 3 static excitation system. In AC excitation system is further divided into two categories. First one is called the rotor excitation system and second is brushless excitation system. So this is the diagram for classification of excitation system. So the first one is DC excitation system. The DC excitation system has two exciters, the main exciters and the pilot exciter. The exciter output is adjusted by an automatic voltage regulator, in short AVR, for controlling the output terminal voltage of the alternator. The current transformer, in short CT, input to the AVR ensure limiting of the alternating current during a fault condition. When the field breaker is open, the field discharge resistor is connected across the field winding so as to dissipate the stored energy in the field winding, which is highly inductive. So this is the circuit diagram of DC excitation system. In this system there is two exciter. First one is called the main exciter and another is called the pilot exciter. So the main exciter and the pilot exciter can be driven either by main shaft or separately driven by the motor. Direct driven exciters are usually preferred as these preserve the unit system of operation. The excitation is not excited by external disturbances. So this is the alternator field winding and this is connected to the main exciter. This is the exciter field and this is the field discharge resistor and this is called the field breaker connected to AVR, means automatic voltage regulator system, and second one is the pilot exciters. This is the field winding of the pilot exciters, this one, and this is called the variable rheostat. By using this we can control the current in a field circuit. So this is the basic circuit diagram for DC excitation system. The voltage rating of the main exciter is about 400 volt and its capacity is about 0.5% of the capacity of the alternator. Troubles in the exciter of turbo alternators are quite frequent because of their high speed, and as such separate motor driven exciters are provided as standby exciter. So the disadvantages of the DC excitation system are: the voltage regulation was complex and the response of the DC system is very slow response. So these are the main drawbacks of the DC system. मीन्स इसमें जो हम वोल्टेज रेगुलेशन कैलकुलेट करेंगे वो बहुत ही कॉम्प्लेक्स हो जाता है कैलकुलेशन, और जो इसका रिस्पॉन्स होता है सिस्टम का वो काफ़ी स्लो होता है. The next one is AC excitation system. The AC excitation system consists of an alternator and thyristor rectifier bridge directly connected to the main alternator shaft. The main exciter may either be self-excited or separately excited. Separately excited में तो हम किसी भी different टेक्निक से हम उसको एक्साइटेड कर सकते हैं. सेल्फ एक्साइटेड जो होता है वो 3 टाइप्स का होता है: सीरीज एक्साइटेशन, शंट एक्साइटेशन एंड कंपाउंड एक्साइटेशन. इन 3 तरीके से हम सेल्फ एक्साइटेड कर सकते हैं अल्टरनेटर को. द एसी एक्साइटेशन सिस्टम मे बी ब्रॉडली क्लासिफाइड इनटू 2 कैटेगरीज, which are number 1 rotating thyristor excitation system and number 2 brushless excitation system. तो AC सिस्टम में हम क्या करते हैं, मेन जो अल्टरनेटर है उसकी शाफ्ट से डायरेक्ट हम थायरिस्टर रेक्टिफायर ब्रिज कनेक्ट कर देते हैं फॉर एक्साइटेशन पर्पस. The rotor excitation system is shown in a figure. The rotating portion is being enclosed by dashed line. This system consists an AC exciter, stationary field and rotating armature. Means armature winding is rotating, means placed on a rotor, and field winding placed on a stator. In case of AC exciter, the output of the exciter is rectified by a full wave thyristor bridge rectifier circuit and is supplied to the main alternator field winding. The alternator field winding is also supplied through another rectifier circuit The exciter voltage can be built up by using its residual flux. The power supply and rectifier control generate the controlled triggering signal. This is the block diagram of rotating thyristor excitation system. In this system, main alternator, this is the main alternator, this is the field winding and this is the armature winding of the alternator. And this is the AC exciter system connected to alternator field rectifier, and after rectifier the signal sent to the field winding of the alternator. So this dotted line represented a rotating portion of the system. The alternator voltage signal is averaged and compared directly with the operator voltage adjustment in the auto mode of operation. In the manual mode of operation, the excitation current of the alternator is compared with a separate manual voltage adjustment. So this is all about the AC excitation system. This system has some advantages and disadvantages. So the main advantages of this systems are, this system has fast response compared to DC excitation system, simple to construct, and the cost of this system is low compared to the DC system. So these are some advantages of AC excitation system. The disadvantages is the response rate of the thyristor is very low. इसमें हमने जो thyristor bridge का यूज किया है तो उसमें जो thyristor का response होता है वो बहुत ही low होता है. सिस्टम का ओवरऑल सिस्टम का जो रिस्पॉन्स है वो तो फास्ट होता है, बट thyristor रिस्पॉन्स जो होता है वो वेरी लो होता है. So this is the main drawbacks of the excitation system. The second is brushless excitation system. This system is shown in a figure, the rotating portion being enclosed by a dashed line rectangle. The brushless excitation system consists of an alternator, rectifier, main exciter and permanent magnet generator. The main and the pilot exciter are driven by main shaft. The main exciter has a stationary field and a rotating armature directly connected through the silicon rectifier to the field of the main alternator. So this is the circuit diagram for brushless excitation system. This is the main alternator field and this is the alternator main alternator field winding. This is called the main exciter. This is permanent magnet generator. and this is thyristor bridge circuit. So by using this system, we can excitate the alternator. The Boylet exciter is the shaft driven permanent magnet generator having rotating permanent magnet attached to the shaft and a three-phase stationary armature which feed the main exciter field through silicon rectifier in the field of the main alternator. The Boylet exciter is a shaft-driven permanent magnet generator having rotating permanent magnet attached to the shaft and three-phase stationary armature which feed the main exciter through three-phase full-wave phase-control thyristor bridge. The system eliminates the use of commutator, collector and brushes having a short time constant and a response time of a fewer than 0.1 second. The short time constant has the advantage in improved small signal dynamics performance and facilitates the application of supplementary power system stabilizing system. तो एक्चुअली इस सिस्टम को ब्रशलेस सिस्टम हम क्यों बोलते हैं? बिकॉज इन दिस सिस्टम वी कैन एलिमिनेट द कम्यूटेटर एंड ब्रशेस. So this is called the brushless excitation system. The advantages of the brushless excitation system are it is more reliable compared to the DC system, or we can say that the reliability is excellent of the system. The flexibility of the operation is also good. The brushless system response are good. There is no moving contact in the brushless system, so maintenance is low. So these are some advantages of brushless excitation system. So the disadvantages of brushless system are this system, the response is slow. In the system, there is no fast de-excitation. So these are the drawbacks of brushless excitation system. Next is a static excitation system. In the system, the supply is taken from the alternator itself through a three-phase star-delta connected step-down transformer. The primary of the transformer is connected to the alternator bus and their secondary supply power to the rectifier and also feed power to the grid control circuit and other electrical equipment. This is the circuit diagram for static excitation system. This is the main alternator. This is the main alternator. This is the field discharging resistor. So this is called the SCR cubicles, and this is the rectifier transformer. This system has a very small response time and provides excellent dynamic performance because this system is used solid state devices to excite the system, And this system reduced the operating cost by eliminating the exciter windage losses and winding maintenance. So the advantages of a static system are: this system is more reliable. We can say that the reliability of this system is good. The flexibility of operation is also very good. Static excitation system response are excellent. This system is small in size, low losses, simple to construct and give high performance. So these are some advantages of static excitation system. Now the disadvantage of static excitation system is it requires a slip ring and brushes. मीन्स इसमें हमें स्लिप रिंग और ब्रश की ज़रूरत होगी, तो इसमें स्लिप रिंग और ब्रश का जो लॉसेस हैं वो इसमें ऑलरेडी ऑकर होंगे, और कॉस्ट ऑफ स्लिप एज वेल एज द ब्रश इंक्रीज द ओवरऑल कॉस्ट ऑफ द सिस्टम. So next is the references of this presentation. So these are the references of this presentation. And thank you for watching this video.